So you guys read chapter 16, hopefully, and there's a lot in chapter 16, and we're going to kind of divide chapter 16 up into 3 different days. Today we're strictly going to talk about the binomial distribution. When you read chapter 16, it talked about something called Bernoulli trials. So hopefully you read that and you saw that name. Bernoulli is just the mathematician that kind of finalized this distribution. Bernoulli trials are both geometric and binomial. Both of those are considered Bernoulli trials. And when they say trials, they mean like out of a set of fixed trials in the case of a binomial situation. Today we're just going to focus on binomial, and we're going to do the formula. So if you have a formula sheet, you're going to need that today. You'll also need a graphing calculator, so you need both of those things. So if you need to grab a calculator, go ahead and do so. Check them out. All right, so in order to decide whether or not a binomial situation is appropriate, there's some formulas that we're going to use. So you'll need your formula sheet out, like I said. There's a checklist. We're going to check 4 different conditions, and so I've written them up here on the board. The first condition is independent trials, and what I mean by that is that one trial would not affect the other. So if we were drawing cards, it would have to be with replacement because you don't want those probabilities to change. Rolling of dice are independent, spinning of spinners are independent, that kind of thing. Excuse me. The book called the second condition that I've written up here the success-failure condition, and that just means that you either are or you aren't, okay? What is determined as success? We're going to look at an example in a couple of minutes, but let's say that we're talking about drawing a card. The success would be a heart. So we would have, you could draw a heart, or you could draw, well, not a heart. I don't care what other suits there would be. I know that they exist, diamonds, clubs, whatever. I don't care about that. When I say success, failure, I mean the success is what you're looking for, and the failure is what you're not looking, is just everything else. Okay, like the complement, if you want to think about it that way. Probability, we're going to denote that as the letter P. It is going to be the same for each trial. So we're talking about with replacement, so that means the probabilities aren't going to change. Number 4 is that the number of trials is going to be fixed. And this is actually one that is only for binomial. These top 3 are also for geometric. Okay, so geometric also. We'll talk about geometric more on Tuesday. But you should have read a little bit about geometric when you read the chapter. The number of trials is fixed. Now, if you look at your formula sheet, about midway through the second column, there's the formulas for the binomial, and there should be 3 of them that I want you to pay attention to. The first one looks like, well, hang on, looks like this, okay, this middle one here. The only thing that's different, and if you could, go ahead and look at your formula sheet so you can see which ones are, what letter is different. There's 2 things different about what I've posted, which is what the book says, versus what's on your formula sheet. They're a little bit different. What do you notice is different between a formula sheet and what you see on the smartboard? One of the letters is different. It's K in a place of X, okay? So I tend to say X, your calculator uses X, the textbook uses X, but AP has to be funny, so they use the letter K. That's fine. So you can just say K here if you want, K here, and K here, okay? Either one is okay. Oh, I guess this would be a K too, right? Fine, whatever. We need to talk a little bit about this first piece of the formula, the thing with the brackets. Anybody have any idea what that is? When you read the chapter, did it talk about the calculation at all about what that is? N choose K? If I said 5 choose 2, that's how that's read, by the way, 5 choose 2. In Algebra 2 or Advanced Math last year, you should have learned about this. It's not matrices. Another way to write this would be 5 choose 2. Maybe you've seen it written that way before. Okay? Both of those notations, by the way, mean the same thing. All this would be you have 5 things. How many different ways can I choose groups of 2? Okay? Does that sound familiar when you did permutations and combinations last year a little bit? Okay? I'm going to show, there's a long way to do it. Here's the long formula, by the way, right underneath it. I'll never ask you to use this formula, but I wanted to at least show it to you. These little exclamation points, anyone know what those are? They're factorials. And factorials simply are this. If I have 3 factorial, it just means 3 times 2 times 1. If I have 4 factorial, it's 4 times 3 times 2 times 1, and et cetera, and so on. Okay? So factorial is just a mathematic calculation. That's all it is. And this is the formula for your combination. Okay? The nice thing is that I'll really never ask you to go through and use this formula because the calculator has that combination function. So let's all find it real quick, if we could. I want us to find what does 5 choose 2. So grab your calculator for me. Oops, can't see my smart board here. You're going to go to math and probability. So math, PRB, is what you should see. Off the board there. Oh, nice. Okay. So let's see what we got. So we're going to turn our calculator on. Again, we want it, since we said 5 choose 2, we'll have to plug in the 5 first. Then we'll go to math. And then we'll go over to PRB for probability. And you'll see here the permutations. We want the combination, so we'll choose option 3. 5 choose 3 looks like this. And the answer is 10. There are 10 ways to be able to do that. Okay? We okay with how to do that on the calculator? I'm going to try to see if I can get, oh, it just wants to close automatically. All right, well, smartboard's acting funky. Love it. The other 2 formulas that you'll see that are specific to a binomial are these down here at the bottom. They are the mean and the standard deviation formulas. And they should also be on your formula sheet, are they? Do they use Q? I don't think they use Q on your formula sheet. What do they use? What's different about your formula sheet versus what you see here? Right. So Q is just 1 minus P. Okay, same thing up here in the yellow highlighted formula. Q is just the complement of P. Okay, so Q is just 1 minus P. And what's nice is that your formula sheet doesn't even, it just uses 1 minus P, so you don't even have to know that. But I believe your textbook uses Q. I tend to use Q too, but just we're okay with that. Okay? How might, well, we'll come back to when we would use this in a few minutes, okay? We'll use these formulas, or at least the mean and standard deviation formulas in a minute. But what I'd like to do is just start off by trying a problem, okay? And any time that you think you might have a binomial situation, you'd like to be able to use this formula, you have to check the conditions. So let's read this example, and let's do a little checklist, 1, 2, 3, and 4. And let's decide, is it in fact a binomial situation? Okay? And you're going to have to get into the habit now of checking conditions. And this is something that we're going to do, especially when we get into the second half of the semester, or the second semester. We're checking a lot of conditions. But binomials have 4. What was the first one? Independent. What does that mean in this situation? What doesn't affect? Like, give me context of the problem. Noelle.
The outcome of A won't affect outcome of B.
Perfect. What does that mean, the context of this problem? The probability of what?
Oh, okay. So is the probability of rolling of, say, a 1 on the first try won't affect the outcome of B.
Right. Right. So each roll of the dice is independent of each other. That's what we want to say. Okay? So the rolls are independent. Rolls are independent. We're going to put a check. Yeah, that first condition satisfied. What was the second condition? 2 outcomes, a success-failure condition. Okay, so what are the outcomes here? We are looking for a 3. A 3 is considered a success in this situation. Do you agree? So we really care about 3s and not 3s. I don't care what the other numbers are. It doesn't matter to me if it's a 4 or 1 or a 6. I don't care. If it's 3 or it's a not 3. So does it meet that condition? It does. So success, failure for 3s work. Okay? Question, Cameron? We're going to get to the exactly part in a minute. That means something else right now. We're looking for just 3. Okay? What's the third condition? So the P is, and what is the P here? What's the probability of getting a 3 on any one roll? 1 out of 6. Very good. So because P is equal to 1/6 at any given time, we're good on that condition. And what's the last condition that we wrote down? Set number of trials. How many trials am I doing here? 20. I'm rolling the dice 20 times. So I'm going to say that n, which is our number of trials, is equal to 20. So I have, in fact, checked the conditions. All 4 have been satisfied. Now I am free to use the formulas. Okay? So in this case, we're going to use our formulas. Remember what it is. I'll use the one on your formula sheet. N choose k times p to the k times 1 minus p to the n minus k. I believe that's exactly what the formula on your formula sheet says, correct? Double check me. Is that right? Okay. So we know, let's fill in the numbers, and then I'm going to show you how to type it into your calculator. What is n? 20, good. What is k? How many successes am I looking for? 1, exactly 1, right? So I'm looking for exactly 1. That tells me that k is equal to 1, okay? That's that information. So 20 choose 1. What was p? What's the probability of success? 1 out of 6. We're going to raise that to the what power? The first power, very good. And then we have 1 minus 1/6 to the 20 minus 1 power. Okay if I just write 19? 20 minus 1? Is it okay if I write 5/6 rather than 1 minus 1/6? Is that okay with you guys? To kind of put that little step in there? So just make this a 5/6? Any questions on where that came from? Good? All right, so we need to figure out how to plug this in. Remember that the first part, the 20 choose 1, is that combination formula, right? So that means I'm going to have to use that on my, do that on my calculator. So I want you to, on your calculator, to type 20 choose 1. I'm not going to do it on my overhead calculator because it's going to make the whole smart thing go away. But tell me what number that is. If I have 20 things, how many different combinations of 1 would I get? It's just 20, right? So now I'm going to have 20 times 1/6 to the 1 times 5/6 to the 19. I'd like for you to type all of it in for me. Tell me what you get. You don't want to use a decimal. You do want to use a full probability. So let's try it. Maybe move it out of the way. There we go. Or not. Come over here. It doesn't want to. Okay, enough. So we know that 20, choose 1 is 20 times 1/6. I do type in 1 divided by 6. Raised to the 1 power. Bring it down. Times 5/6. Notice I'm using my parentheses. That's important. Raised to the 19th power. And I get 0.1043. I'm going to say about 4 decimal places is a good rule of thumb here. Okay? So 0.1043. So about a 10% chance of getting exactly 1/3 when I roll the dice 20 times. Okay? Any questions so far? Let's try a different one. Okay? What happens if we roll the same situation, we're rolling it 20 times. The question becomes different now because I'm asking you, we want at most 2 3s. We've already checked those conditions, so we don't have to go through and do that again. Okay, we've already done that because it's the same scenario. But what changes? K changes. Okay, so I'm going to write a little. I like to write a number line. So you have no 3s, 1 3, 2 3, 4. And then we're rolling the dice 20 times. What does at most 2 mean? I could have 0. I could roll 0 threes. What else could I do? 1 3 and at most, does at most 2 include 2? It does. So that means that at most 2 is 2, 1, or 0. Would you agree with that? That at most 2 represents that situation. So I have 3 different K's. So I've got to treat them 3 different ways and add them together. Okay? So that's what we're going to do. We're going to say 20 choose 0, and then type in what I know. Or 20 choose 1. Or 20 choose 2. Now you are going to need to type in your choose, your first part. I'm going to highlight the ones that you should really find first. And then you could, oh, not that one. All of these, remember these aren't fractions. Those are combinations. 20 choose 0, 20 choose 1, 20 choose 2. So I want you to find those numbers for me. Tell me what you get. And then we'll type everything else in at the same time. I'm going to leave those blank. Because the way you type in 20 choose 2, 20 goes first, then you do your NCR, then you do your 2. You'd have to put parentheses around that and then go on. And to me, that's way too much to do at one time. It's possible, but you have to be really careful with your parentheses because this and that are on the outside of the NCR. Yes? Mm-hmm. It's 18. Thank you. That's what I meant. But you can, April. I mean, you can, in theory, do it all at once. But I just want you to be careful. Because if you make one little mistake, because it goes off the screen, it'll be hard to see it. Okay? So what's 20 choose 0? 1? Right? Okay. What's 20 choose 1? 20. And then what's 20 choose 2? Okay. 190? Is that true? Can someone verify? Good. Okay. So now at this point, you can type everything in. Just be really careful about your parentheses. Okay. You want to make sure that everything goes in the way it's supposed to. And tell me what you get for at most 2 3s. I'm going to do it with you. See if we get the same answer. All right, I got 0.3287. See if you get that same number. Are y'all still typing? I'll tell you the shortcut at the end of class. I know it. You don't know it yet. It's a fun shortcut. Because this is long. And you just take it back. Right? There's a shortcut. I'm making you use the formula for now because the formula has been seen on the exam and I want to make sure you know where all the parts are for the formula. So we're going to use the formula for most of today, but I will show you the shortcut calculator at the end, okay? Make sure you get the same answer as me though. Byron. You a Hornets fan? Why the hat then? Because you like what? Oh. Did you get the same answer, James? I didn't call you David. It's a good day for me. All right? All right, what do you think about the second question? Let me put this up here. More than 2. I want more than 2 threes. Yeah. Esmeralda's right. More than 2 means we're looking at, well, not including 2. More than 2 doesn't include 2. Would you agree? It would start at 3 and go all the way up. All right, go ahead and get started, and I'll tell you what the answer is. I got 0.6713. What did I do? If at most 2 is 0.3287, y is more than 2, 0.6713, because they're complements of each other. So it's just 1 minus 0.3287, right? Right? So if you can use that idea of complement, look at how much time that saves us. Esmeralda's over there freaking out going, you're really going to make me do 3 to 20? Right? Miss Macker, you crazy. Right? No, I'm not going to do that. It's just a compliment. Okay, good. Doing okay so far? Not bad, right? Right? All right. Let's do a couple more. Oh, this is one that is just like what we did. How about this one? More than 7. Oh, did we do a more than already? Oh, not from this way. All right, more than 7. What do you think? More than 7 threes. Again, same situation. We have, I'm going to say 10 trials now, because I don't want to go all the way up to 20, because, you know, Miss Macker, you crazy, right? I'm not doing that. Let's just say 10 trials this time. So we're going to change the number of trials. But still a binomial situation. Have a success failure. They're independent. More than 7 threes. Yes, Jennifer's exactly right. We need to make sure we always have 0. It's possible to have no 3s at all. So you always want to include that. I agree. More than 7. Are we okay with me saying that it starts at 8 and goes all the way to 10? Would you agree? Agree with that? I agree with that. All right, so go ahead. So what would it be? It'd be 10 choose 10 through, thank you, 10 choose 8 times 1/6 to the 8, 5/6 to the 2, or 10 choose 9, 1/6 to the 9, 5/6 to the 1, or 10 choose 10, 1/6 to the 10, 5/6 to the 0. Go ahead and tell me what you get. E, when that calculator gives you that E to the negative, that means you're moving the decimal place to the left that many times. So it's just the calculator's way of doing scientific notation. So I've handed you each a practice binomial sheet. You'll notice that you have several different binomial situations here. I do want you to do the checklist for each group. So for example, 1 through 4 are all the same binomial group. So I just want you to do a checklist for 1 through 4, a checklist for 5 through 10, etc. Okay? Just going to do it off into the margins, 1, 2, 3, 4, and then put a little checklist to make sure it satisfies each of those. Okay? You are going to need to use the formula. I am okay if you just write the formula and then plug in your answer. Okay? That's as much work as I need for you. And then in a little bit, I will show you the shortcut, okay? But not until you work on it with the formula for a while. So I have a question for you on the homework assignment that you're looking at right now, or the homework, it's classwork, sorry. The first 4 problems, some of you are on to the next group, and that's fine, but can we revisit the first 4 for a minute, where it's talking about a coin being flipped 6 times? So you have a coin that's flipped 6 times, which means you have a probability of getting ahead is what? What do you find it to be? Well, I'm not for it, but I'm talking about just regular p. What's the probability of getting ahead on any one time? Is 1/2. And then n was 6. Would you agree? And then what was x? Well, doesn't that change every time? Right, that's fine. Okay, so my question becomes this. On average, how many heads do you expect when you flip the coin 6 times? How do I answer that question? Well, the formula is in front of you, right? It's on your formula sheet. The mean is what we're looking at. That's what average means. Don't you agree? So on average, so what's the formula here? N times P. So it's going to be 1/2 times 6. So the mean is N times P, which is just 1/2 times 6, which is just 3. If I asked you with what standard deviation, what would you do? Is that formula available to you as well? I believe it's right underneath it on the formula sheet. Do you agree? It's a square root of, and the reason I'm going over this is because on your homework that I just texted you, by the way, if you got it, is out of the textbook, this will come up, okay? So the standard deviation formula is the square root of NP times 1 minus P. So in this case, it's the square root of 6 times 1/2 times 1/2. And so that standard deviation is 1.225. Because 1 minus 1/2 is also 1/2. Okay? So anyway, I just wanted to make sure that you realize that some questions in your homework are going to talk about on average and standard deviation. Those formulas are provided. They're on your formula sheet. So don't let those freak you out. Okay? All right, keep working. Maybe. Oh, there it goes. All right, so let's go ahead and go back to the beginning. And I'd like to show you the calculator shortcut. We've now done the formula several times. And I'd like for you to find on your calculator the distribution button. So look on your calculator and find the distributions. We'll be using this distribution button quite a bit. Do you see where it is? Okay, let me find my, well, there it is. The distribution button, if you turn on your calculator, here we go, we'll clear it out, is second bars. And you'll see a list of them. We're going to get to normal distributions next week. So you'll see those coming up. You probably used those last year. But now we have, if you keep scrolling, we have 2 up here binomial distributions, binom PDF and binom CDF. We will actually use both of them. PDF stands for probability density function. And it simply means when you have an exact situation. So on this first problem that I have here, I'm looking for rolling exactly 1, 3. That's what the question says, correct? Exactly 1. So we're going to hit binom PDF because PDF is what we're looking for. Maybe. Smartboard is not my friend today. So click binom PDF and you will see it brings up a prompt of a couple of different things. So we have binom PDF and then it asks you a series of questions. How many trials did we have here? 20, so type in 20 for trials. What's the probability in this particular problem? It's a dice, so what was it again? 1/6, we'll type in 1/6. And then in this case, our x value was just 1. We wanted 1 of them. Oh yeah, I meant 1/6, thank you. There we go. We're using PDF because of the word exactly. The word exactly tells us to use PDF, okay? The x value was 1. We'll click paste, and it says, are you sure this is what you want? I say, you betcha. We hit enter. Lo and behold, we get the same answer. Yes. 1, because it said exactly 1. Okay? It gets better. You ready? It's like the magic calculator, right? All right. So it does get better. Let me show you how. If we look at this one, at most 2 3s. So at most is not an exact situation, so that means that we are looking at the cumulative density function. So that is not an exact, but again, I said a cumulative. So you're going to go back to your distributions, second vars. We'll scroll down, and we're looking this time for binom CDF. The cumulative density function, unfortunately, but not in this case, unfortunately, but it's important to know that it only does less than. Whatever number and less than. So in our case, we're looking here at most 2 3s. So we want to include 2 and everything less than. Would you agree? So we're good to use this function, at most 2. So again, we had 20 trials. Our probability of success was 1/6. If I can type that in correctly, 1 divided by 6. And our x value would be 2, because it includes that number, okay? That's why I circle it and the number line and draw it to the left. That's what it means. So it's going to include 2, 1, and 0 in this. We'll go ahead and paste, you betcha, and we should get exactly the same answer, 0.328. 87. James. Okay, I'm going to come and see you in just a second. Okay? Thank you. So let's look at what happens in a more than situation. Less than we know, right? We can do less than. It's just that number and CDF. That's fine. But a more than's a little harder. So let's think about how we could use a calculator, in this case, in a more than. Remember, down here in my number line, I have drawn 8 and above. That means more than 7. Do you agree? Because the calculator will only do less thans, what if I found that? Then I would subtract it from 1. That's exactly right. So that's what I'm going to do. You guys are amazing today. So it's exactly right. So I'm going to use the complement as well of 7 and below. Shh, guys, watch. So what you're going to do is you're going to use the complement at the beginning. We know we have to use the complement, 1 minus. And then I go ahead and do my binomial. Come down. Oh, you want a CDF or a PDF? Because it's a cumulative. Good. This time, if you remember, we changed the trials to be 10 trials. And our p-value is, our x value is going to be what? 7, because that's what I want to subtract off, right? I want 7 and below gone. So I'm going to put a 7 here. Oh, that's weird. I typed 7 on here, and it showed up there. Let's see if that works. Look at that. I'm typing that on my computer. Sorry. These little things in life. Oh, but that doesn't work. Okay, fine. Sorry, I just got really excited. All right, sorry. It was what was it, 7? Okay, and then we'll paste. It is the 1 minus. We'll go ahead and hit enter. And it's the same darn answer that we got before. Okay, that little e and the negative does mean you subtract, that you move the decimal place to the left 5 times. I think this will be helpful to you. But what I will tell you is that on this particular sheet, I want to see the formula. Okay? That doesn't mean you have to type in the formula. You can type it in shorthand, but I want to see you written out. Does that make sense? Okay. You're welcome. Your homework is going to be in Chapter 16, 15 through 20 all. You'll also need to finish the worksheet if you did not do that in class.